Okay, we shall start the event. Ladies and gentlemen, welcome to the second day of ACISE and ICESH 2021.
Yesterday was a very insightful and engaging day, both from the keynote speech and the parallel session. I am sure that all of our participants are getting a lot of new perspective and new ideas.
Yes, that's right. And I'm so excited. We are so excited because today we still have plenty of speakers that will share their ideas with us today. So, ladies and gentlemen, do not worry because there will be more insight coming your way.
Yes, I'm agree with you, Sabam. And also we would like to say a very warm welcome to our distinguishable guest and thank you for attending our conference today. The Honorable Vice Rector for Research and Innovation of Diponegoro University, Professor Dr. Insinyur Ambarianto, Master of Science.
The Honorable Dean of Engineering Faculty, Diponegoro University, Professor Dr. Insinyur M. Agung Wibowo, Magister Manajemen, Master of Science. The Honorable Head of Department of Industrial Engineering, Diponegoro University, Dr. Ratna Purwaningsih, Sarjana Teknik, Magister Teknik. The Honorable the Chair of ACISE and ICESH 2021, Dr. Engineer Novi Susanto. The Honorable Heads of Department in Faculty of Engineering, Diponegoro University. The Honorable President of PEI, Perhimpunan Ergonomi Indonesia, or Indonesian Ergonomics Society, Professor Yaserli, PhD, CPE.
And also to our keynote speakers, Professor Jose Orlando Gomez, PhD, CPE, from University of Rio de Janeiro in Industrial Engineering Department and Graduate Program in Informatics. Professor Paul Yu, PhD from RMIT University, Vietnam. Professor Juliana Sutanto, PhD from Management Science Department of Lancaster University. Dr. Richard Hanowski from Virginia Polytechnic Institute and State University. Anton Dodi Susanto, Sarjana Teknik, Magister Manajemen. From Coca-Cola Euro-Pacific Partners Indonesia. And also Dr. Insinyur Heru Prastowo, DEA from Diponegoro University.
We would also like to welcome our invited speakers. First, we have Associate Professor Ferry G from Edith Cowan University, Australia. Second, we have Dr. Rifki Ismail Sarjana Teknik, Magister Teknik from Center for Biomechanics, Biomaterial, Biomechatronics, and Biosignal Processing. We also have Professor Dr. Ari Susanti, Sarjana Teknik, Magister Teknik from Diponegoro University. And we have Dr. Ratna Purwaningsih, Sarjana Teknik, Magister Teknik from Diponegoro University.
We're also very grateful and thankful for every sponsor that support and help our event, especially for Javatech Agro Persada and CBiomes, or Center for Biomechanics, Biomaterial, Biomechatronics, and Biosignal Processing. Welcome and thank you for joining us again in our second day of ACISE and ICESH 2021. And I just want to give a little reminder that in the last session of our joint conference, we will announce many awards that every participant can get from the one and only our sponsor, Javatech Agro Persada.
Yes, that's right. With the conference theme of the roles of information system, human factors engineering, and ergonomics in preparing the post-pandemic new way of working life, today's plenary session will touch more on that topic. Now, before we start our session today, I'm inviting all of you to see the beautiful of our traditional Javanese dance to know more about our host city, Semarang, Indonesia.
Sudah dan. Oke, oh ada background sekarang. Bisa.
So yeah, that was a short glimpse of one of our traditional dance in Indonesia, which is traditional Japanese dance. Now we are going to begin the conference, but first let me inform you a little guide of how to give a questions in our keynote session. So for the Q&A session, we will use Slido. First, every question can be asked anytime via Slido and will be answered in the last session of the keynote session. To access Slido, you can open it via link in the chat box or kindly open www.slido or Sierra London India Delta October. Then you can enter the code provided by the committee or scan the QR code that will be shown when the Q&A session. Before you ask a question, please kindly mention your name and your affiliation before the question. And that's okay if you want to ask in Bahasa Indonesia and use raise hand feature instead, if it is more comfortable. So to start our event today, we will have the first keynote speech from Professor Jose Orlando Gomez from University of Rio de Janeiro in Industrial Engineering Department and Graduate Program in Informatics with topic Activity Analysis and Systemic Approach in Developing Countries, Examples in Brazilian Industries.
We would also like to invite Dr. Johanna Reina Octavia as the moderator of this session. Dr. Johanna Reina Octavia is an associate professor at the Department of Industrial Engineering and also the head of Center for Ergonomics, Parayan Catholic University, Indonesia. to Dr. Johanna Rene Tavia. The time is yours.
Yeah, okay. Thank you, Sabam and Philia for the introduction. Also, thank you, Bu Novi, for inviting me to be the moderator of this session. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Selamat pagi, Bapak Ibu, para hadirin, para peserta seminar International Conference ACISE and ICESH 2021. Welcome to the first session of the keynote speeches of this morning. I hope that we are all in a healthy condition despite the pandemic situation. And for those of you who are not who are feeling unwell, I wish you a speedy recovery, and also get well soon, and we'll be back in track. So very delighted and honored to have our two distinguished keynote speakers. Here we have Professor Jose Orlando Gomez, PhD, CPE, and also Dr. Richard Hanowski. Very good evening to Professor Jose and also Dr. Richards. I believe that it's evening there in Brazil and also in the US. So a very good evening to both of you. We are here in the very early morning and you are there in the very late evening. So despite the time difference, we managed to come together to this virtual meeting or virtual conference, and we are very delighted and honored to have you both here. So before I begin, let me get us to the keynote session. So we divide these keynote sessions into two. So we will first hear from Professor Jose for 45 minutes for his talk. And then we will then go to Dr. Richard for his talk as well. You may post your questions as it comes along in the chat box or in Slido, but you also give you time if you would like to post your questions directly by raising your hand during the Q&A session. And you're also, of course, welcome to post your questions in Bahasa as well, and we will help you to translate. Okay, so let us start with the first keynote speaker of this morning. Welcome, Professor Jose Orlando Gomez, PhD, CPE, to our conference. So let me introduce you. Give a brief introduction before we start. So Professor Jose is a full professor at Federal University of Rio de Janeiro, Industrial Engineering Department and Graduate Program in Informatics. He's also an Associate Director of International Relations for BRICS, Escola Politecnica. But the most important, as Professor Yasyari reminded me that Professor Jose is our newly elected president of International Ergonomic Association just last month. So first of all, on behalf of our Indonesian Ergonomic Society, congratulations, Professor Jose, for the election. We are very honored to have you here. Well, unfortunately, it's virtually, but of course, when it's possible, when the pandemic is over, we are very excited if we can have you here physically in Indonesia, and then we visit the beautiful places and eat a delicious food here in Indonesia. So Professor Jose, teaching, research, and interests are in human factors engineering and ergonomics, of course, also especially in work safety and cognitive and resilience engineering in complex system. So Professor Jose will give his talk for 45 minutes with the title Activity Analysis and Systemic Approach in Developing Countries, Examples in Brazilian Industry. To Professor Jose, the floor is yours. You may begin.
Thank you very much for your kind presentation. Can you hear me well?
Yes, perfect.
Is okay? Okay.
Yeah.
So let me try to share my slide. So, okay. It's okay there? Okay, thank you. So first of all, I would like to thank you, Indonesia Ergonomics Society, to invite me for this important conference. It's a great pleasure to be here with you today. And my good morning to everyone. Even in Brazil, a great pleasure to participate. And I would like also to thank you publicly the support we received from Indonesia Ergonomics Society, and we are eager to collaborate and to develop projects with Indonesia Ergonomics Society, PAY. So thank you very much. Today, despite to be president of IEA, I would like to talk about my experience as engineer and ergonomist. In Brazil, we call production engineering. What do you call industrial engineering? But it's the same. And I'd like to show you my agenda today. I'd like to start briefly mention the IEA mission goals. Then I'd like to emphasize and give you some fast picture of the Brazilian history on HFE. And then to go through cases in Brazilian industry and conclude talking about Industry 4.0, digitalization of the economy, and try to point some directions to go. So moving to IEA, I would like just to mention that our goal when we say IEA is not only the executive committee, IEA is a global federation of federated and affiliate society on human factors and ergonomics, distributed worldwide. And our mission is to advance and expand the scope of application of HFE to society. To do so, we are guided, in fact, by 7 policies I would like to mention briefly, but we will discuss later on, because these policies came from our experience in the field, applying HFE and guiding and governing federated societies, networks, and also at the executive committee of IEA. The first one I'd like to mention, is so important for us now, is the stakeholder engagement. So if we would like to develop HFE, we should embed it in the real world of work. And to do so, we needed to be involved since our training with the stakeholders such as industry, such as the regulators, such as the unions, such as civil societies, NGOs related to the human work. And also I'd like to mention briefly, it's our policy number 2 is to collaborate and reinforce the IEA networks. This is a policy that have been implemented in last terms because IEA doesn't have the capacity to reaching out the regions, and the IEA networks came to fill the gaps, like EULA Ergo in Latin America, Ergo Africa in Africa, FIS in Europe, CIANIS and ACD in Asia, and recently the BRICS countries network. So this is really important for us. Following this policy, we have the number 3 is to contribute to science, technology, and practice, and is directly related to the future of work as well, because we try to address some issues related to the development of disruptive technology and the impact of work. But to do so is necessary a strong relationship with the universities in which the research is promoted mostly, and also the education of the researchers, the education of the trainers and practitioners is done. So in order to improve our relationship with the external organizations, we defined recently a new policy to work with such big organizations like ILO, International Labor Organization, and also to work with the regional and national offices, because ILO also is working very hard on HFE matters and legislation and regulation, but also in the future of works. Future of work is another policy we are we have defined recently. Why this policy? Is because we're facing a very complex context worldwide. Developed and developing countries are facing in different levels disruptive technology, but traditional knowledge, and even informal economy. So, of course, developing countries have a vast majority of the workforce in informal economy. And this is a big challenge for us, because when we talk about Uberization of the workforce, we're talking about disruptive technology plus informal work. We have in Brazil these issues, and other developing countries have the same. But how we can deal with this situation? And to do so, I would like first introduce a brief history of the Brazilian ergonomics. In Brazil, we had the first courses in HFE at the University of São Paulo in the 60s, when the country started to industrialize. And this got traction with the first courses in industrial engineering in the 70s, last century, and also with the first graduate courses on industrial engineering. But a turning point in Brazil related to HFE was the influence from the French approach introduced in the country since the 70s, last century, by Professor Wisner. He used to be the head of the Lab of Ergonomics of the Conservatoire of National Arts and Professions in Paris, in which since the 50s have been developed very insightful research in human factor and ergonomics. And briefly, this is the approach I will discuss later on, but distinctive characteristic of this approach is to put the ergonomist, practitioner or researcher or future trainer to go to the field, to be trained in a context-based. This is, in our case in Brazil, made the difference. And we can see, based on the research I tried to present briefly today, like the cases I tried to present. But not only the train through the university. They had a crucial role in Brazil to develop HFE. This is really, really important. And this role will influence the first legislation on HFE, but not only. The workers' union had an important contribution at that time. In the 80s, we had the first standard on HFE, the NER 70, that have been improved along the years. And also it's important to mention that during the 80s start the first PhD programs on HFE. That means PhD programs on industrial engineering in an area, a sub-area, concentration area on HFE. So human factor ergonomics in Brazil developed like a mandatory curriculum for industrial engineers. And right now, we should have in the country around 1,600 courses on industrial engineering. And in each course is mandatory at least 1 or 2 courses on human factors in ergonomics, but also in graduate programs. This is another important point to mention that led not only to have the legislation, but also to have the Abergo Foundation in 1983. In this timeline, you can see over the map. In 1984, Abergo, the Brazilian Ergonomics Association, was federated, was admitted at IEA. And following this movement, in 1997, we start a movement, a work team, a teamwork to define, to design and implement the Brazilian certification system. We had this system during implementation around 15 years to be accepted by the Brazilian society, by industry, by regulators, by government. And then we sent this system to be endorsed by IEA. We decided at that time, firstly, to implement. And it's important to mention that we started to certify practitioners, to certify people in 2004. But we realized in 2010, 12, 13, that we need to accredit the courses, and this course necessarily should have practical training, along with to have theoretical training, methodological training, but a kind of residence, a minimum train in the field in terms to perform and to be equipped in terms of professional to make the ergonomic organalysis and to make the job. And this is a level of specialization. That means after the undergrad course in each profession, it can be any course from lawyer to psychologist or social science or engineering, etc. But he can go and study human factor and ergonomics, even industrial engineering graduate course, master and PhD. This gives us very strong multidisciplinarity and the possibility to go to the field in a multidisciplinary team. But not all is flowers. Since 2017, we have been assisting a deregulation of the labor legislation, and now from more than 100 million workforce workers, we had more than 55 million in informal economy, what is not good because the legislation, they don't have protection and so on. Moving ahead, just to mention briefly a schematic model of the approach developed in Brazil based on activity analysis, as you can see in this triangle. The activity is the work itself, is the sharp end, but it's necessary to understand other levels of the organization, and outside the organization, the influences of legislation, governance, moral, social norms, and beliefs, the culture level that could influence the activity in the workplace. And it is necessary also to understand that the activity is influenced by all these levels, but also is part of the job of the ergonomist to map, to understand and collect data about the influence of what is doing in the workplace and the repercussions in the levels, in the high levels of the organization. So it's a systemic approach and try to understand how is the influence of the blunt end over the sharp end. Example, as we are dialoguing with the engineers here, mostly, the blunt end prescribe the work, but prescribe the task, but don't prescribe the activity. The activity is a consequence of the intelligence of the workers. Consider the context, consider the conditions in which the work is done. So this is the reason we use this term coined by Professor Honegel that is inspired in these decades of research in the Francophone countries, in which we needed to take in account the importance of the work as imagined versus the work as done, and try to understand how this interaction is produced, and try to identify the questions that pose the difficulties or the facilities that facilitate to do the work activity in all levels. We can, with this schematic model, we can understand a manager activity as a sharp end practitioner in the bottom line of the manufacturing plant. But we needed to have in mind that they are articulate. And this is the approach we have been doing in the field. And it's required from the ergonomist or from the research team to have a social construction, because most of the time when we arrive to understand the demand comes from the management, it's related to some topics very familiar to them: quality, logistics, for example, costs, accidents, and so on. At the same time, we need to go to the field, to the bottom line, to the manufacturing process, and capture the activity and modeling the activity of the works in the three dimensions, like physical, organizational, cognitive, and more recently, psychosocial aspects. To make this much more concrete, I'd like to talk today about some examples in which we embedded the research in terms to understand, in this case specifically, the resilience and brittleness in the offshore helicopter transportation system, identifying the constraints during the pilot activity. This work was doing during several years with Professor David Woods from Ohio State University. It's important to mention that in Brazil at the time, in the beginning of 2000, the idea in the research is to understand why so many helicopter accidents in the oil offshore industry in Brazil. As our petroleum, the vast majority is offshore. So we have around 60,000 workers in this industry, and all of them are transported by helicopters. So The methodology to understand, to make this ergonomic work analysis and focus more on cognitive, because it's the activity of the pilot. We, as we couldn't fly because restriction in terms of the system itself, we used to use semi-structured interviews in the field when these pilots used to wait for flying, or the helicopter used to be in maintenance. These interviews are recorded. We transcribe these recordings to analyze data. Then our team is to have pilot experts in this domain to be part of the research team. And each interview, we validate with the pilots in terms of the data we capture. And of course, secondary data we got with the administration, because the entire system is outsourced. We have around 10 companies, and we interview around 50 pilots in a universe of 350 pilots at that time. So here, briefly present to you the constraints we found. And this is the first research in Brazil in this domain. We got into, after a social construction of almost 2 years, we are not contracted by the company. It's the biggest company in Brazil, is the state petroleum company. But we made this social construction through the pilot association and addressing to the outsourced companies. This permits to have access to the pilots, especially to the outsourced helicopter companies that are eager to understand why they are having so many accidents. And you can see we have in these constraints the 3 dimensions of HFE: physical constraints, cognitive constraints, and organizational constraints. I'd like to mention environmental issues like bad weather, presence of birds nearby airport area, is because they used to have close to the airport a big trash field of the municipality close to the campus basin called Macaé. But physical constraints, like you can see, the pilots used to walk after each flight, or for each flight, around 1 kilometer from the hangar to the helicopter. Is very high temperature because Brazil is a tropical country, excessive vibration in the cockpit. And, but not only, we used to have organizational issues around this context. It was emphasized cutting costs policies, and this produced very problematic issues for maintenance, because they don't have the components, the parts of the helicopter in stock. So they should ask to come from America. But this put the helicopter stopped for a long time, and they put pressure for the companies to fly more to guarantee the contract with the oil company. But not only, the salary of the pilots used to be variable, 30% fixed and 70% depends on the flown hours. And this put pressure for the pilots neglected the first signs, alerts that the helicopter requires maintenance. As they used to work each 15 days and have a shift, they used to have a common thought to let the new team will take the helicopter to stop and get maintenance. And this is could erode the capacity and safety of have the fleet in a good shape. But not only this, I would like to mention in the right-hand side, there was a clandestine trade of map that one pilot in the 90s, after one consulting company from Texas worked there, this pilot got the software in which it was located, all the oil rigs and tank ships, etc., because each 15 days or more, they change position. And the location, it was so important for the pilots in order to fly correctly. But not only, the radar system was inoperative. To have an idea, the radar system used to be called by the pilots Steve Wonder, because it's totally blind for the pilots. That means it's not long capacity in terms to monitor the entire area, because sometimes you have a flight like 300 kilometers offshore. Other issues related to organizational aspects, like contingency fleets, small ships are very difficult to land on. Standardization of the identification of the oil rigs, for example, is not in the side of the oil rig, but instead in the helideck. So other issues related to change on the fly for the flight plan, short interval between flights, and so on. All these issues, plus psychosocial aspects, because the vast majority of these pilots come or from the Air Force, retired pilots from the Air Force, mixed in with civil pilots trained. These two cultures are shocking in the cockpit and threaten the safety. So, in briefly, I would conclude this case saying that it takes years to, we have worked along this project for 5 years, and this gives us the capacity to study complex system and try to identify the brittleness in the system. And in the last decade, the oil company, and we present this to the top level of the company, and we explain how they fly. I don't have time to be in detail here, but we have mapped the activity like in one flight, back and forth, just one, because they used to fly 15 oil rigs at a time. We map it and put it in the room 40 meters of the all activities the pilots doing in all the stakeholder organization are involved. This validation with the top level management led them to make change in terms of, for example, the radar system and other improvements in the entire system, and reduce a lot the accident rate. Continue in the oil industry, I would like to understand the engineering sector of the oil company, especially during the pandemic. So the idea is, what is this new normal? Is resilient or brittleness, or we needed to rethink? In this area, is important to mention that during the pandemic, all you can see in Brazil through the headline is true. And I would say, as I live here, much more difficult for the Brazilian population. So these headlines are truly very difficult, especially when you have a federal government negationist. All this is influence, all this work made by the engineering of this oil company, because we are drilling at almost 80,000 underwater. So is our oil is in deep water, and Brazil has been developing this technology, and is very difficult for the Brazilian engineering. But during the pandemic, this situation became much more difficult. In this technology development and production engineering department, what we could say is during the COVID, we had this improvisation working from home. So all the engineers, they lose the social interaction. In fact, in reality, they lose the task organization. This is what I mentioned when I emphasize work as a mesh and work as that. We are engineers. We try to design, we try to imagine how should work the production system. But we have poor training to consider the real activity made by the workers, the task knowledge developed in the company. We don't consider. This is one lesson we have been capturing from our preliminary research in this area. And that is true because the companies try to compensate using, for example, Facebook Workplace or Microsoft Team. But this surprising and acquaintance, surprise encounter in the coffee break and the lunchtime, and even during the corridor encounters, of course, it made it difficult to work in this situation because everybody's working from home. So I would say, based in this preliminary investigation, the extension of the workday is very, very important. The works are working from the morning to the evening and try to accomplish their tasks. So even they have and try to have this interaction, social interaction, the spontaneity is lost by the workers. And this makes it much more difficult because the kind of meetings one-to-many and not one-to-one interaction in which you can, you can develop this task knowledge and understand what's going on, what's going on in the company. And frequently you can talk with the boss of the boss, and have much more information. This kind of mapping we are doing right now, but we can say that COVID-19, and based on this remote work, is dictating, accelerating the digitalization or the implementation of disruptive technology. And not only in the engineering sector, but also in education. We have been experienced in the last 3 semesters working at university. And we can say, after training around 300 students in engineering, that we needed to have a bigger team, a pedagogical team, and also we should have and we should redesign this work system because the students also feel very stressed and very with fatigue and tired in terms to accomplish with this with their learning. So it seems these disruptive drives produced by COVID-19 is a real issue for AGFE people. And we should start to use our own experience to redesign the technology in order to accomplish and have an efficient and effective distance learning system. So move ahead to what we call Industry 4.0 or 5.0 is the same principle. What we need is to investigate in all these fields and have a partnership with the industry that are trying to implement. We should go and work and transform the industry in our lab. This is the idea, because otherwise it would be difficult for us to understand what the physical, cognitive, psychosocial, and organizational requirements to design the work system. In this case, I would say working from anywhere already started. So, as I said, COVID-19 accelerate the situation. So, in our case, separate worker from the work. We need to understand better and try to understand the difficulty the workers, the students, or anyone work from home or from any other platform like Uber, Grab, and so on. What are in the blunt end and in the sharp end the requirements to improve the system? And this is a marvelous lab for us to go through. So it's important for HFE to address these requirements to design a human-centered work system for working from anywhere, and of course to develop a continuous learning and a continuous improvement system in which we need to train much more close the engineers in HFE, not only industrial engineer. I have been experienced with electrical engineers, electronic engineers, computer science. It seems we have a big lack of, a big gap of training on our concepts of HFE. Cognitive aspects is the same. So people are feeling during this time overloaded. So it's a big demand for HFE to design better cognitive interfaces, how to organize the prioritization of the tasks, because if we are working from home, for example, what we should do first, because when we are in the organization, it's much more structured, the sequence we go to work, and work from home is a big messy. So another point important is how to design the human robotic cooperation. It's not so clear, but again, so we needed to embed our students, embed our research in a real industry context and move on along with other science domains, what we call social science and health sciences, to deal with the industrial engineering or computer science. Physical workload, we have a very nice experience with our students. It's incredible because we use their own workplace to be redesigned by them. They made a self-work, ergonomic work analysis. And the result is very, very interesting. We could assist increasing interest and increased interest in research. We are having now voluntary students to be assistants in the course. This is really interesting when they discover by themselves how to improve their workplace. And this is perfect possible to teach these activity analysis, go to the field, even using distance learning. And this we are now using our students, master and PhD, to go deeper and try to redesign the system, because it seems we are in the beginning. And of course, we need to have and to put a special emphasis in this what so-called Zoom fatigue, because it seems is not calibrated yet. We are experiencing that after some half an hour, 40 minutes, for example, the student cannot follow, and we try to change the activity. We are mixing theoretical classes with much more practical with their presentation from the field study. And this is a combination we're testing now, and it seems to be interesting. But again, we, like I said first, we lose the context when we were teaching, and we needed to redesign these platforms and softwares in order to give much more capacity to having context and to interact in a better way with the students. And in conclusion, and getting close to my conclusion, I'd like to emphasize the policy number one, stakeholder engagement. This, we have been experiencing a very important project in Colombia in which we implement a PhD program with these characteristics, but not only. Industrial group in Colombia, in Latin America, are interested in future of work in is an insurance company and is interested how to implement this approach in order to reduce all the issues related to human factor and ergonomics, occupational disease and accidents, increase the productivity and efficiency, safety, and so on. And I would like to mention to our friends from PAY, this could be a project, and IEA, I'm truly convinced that IEA will support, along with the IEA networks, to support, to work with the industry in Indonesia in order to implement some similar projects in order to make improvements and to have experience in order to make this big transformation in the production system relate to the digitalization of the economy. And to conclude, I'd like to mention this very important research made by ILO in Asia, Asian Plus 6, in which it's time for the HFE experts as well to be involved in policymaking. It seems innovation policies and industrial policies should count with our participation. I know that is not so easy, but I'm talking with the engineers here, and I think they have a very good job to do, especially who are interested in GFE, but also the others, because we needed to have a concept that we needed to work outside of our community and a multidisciplinary team and other specialties in engineering in order to develop these policies and to achieve better results, to have HFE since the design of the technology in order to avoid to have a very narrow margin of maneuver, leeway in terms to redesign the implemented system and have a better place and well-being for everyone. So I would like to thank you very, very much. I hope to be on time, Joanna, and thank you for your kind patience with me.
Okay, thank you very much, Professor Jose, for your presentation. From your talk, we were introduced to IEA as the International Ergonomics Association, and also a little bit about the Brazilian Ergonomic Society and how activity analysis and systemic approach is used as one of the main approach, let's say, implemented in the Brazilian ergonomics, and also how it is also used to develop a close relationship with the world of industry. And also, yeah, it also gives us, on the very last slides of your talk, how IEA, let's say, approach the Industry 5.0 or Society 5.0 with all the future work and how we can play a role. And also the very last slide about the Indonesian, it's a very pinpoint to us. So thank you very much for pinpointing this to us, to PEI, to Indonesian Ergonomic Society. And this gives us also an alert, let's say, to collaborate more with the IEA and also the other ergonomic societies in the world. Okay, thank you. I think we can start with the Q&A session, maybe for a couple of questions about now. Before we go to the second keynote speaker from Dr. Richard Hanowski. Let me check. Okay, can we see the Slido? Are there? Let me check first. So please, if you have any questions to Professor Jose for his talk. Okay, maybe we wait a little bit. Okay, I have a question via personal chat here. Yes, Professor Jose, how do you envision the role of IEA and its federated societies in society or industry 5.0 and also the post-pandemic situation? That's the first question I received from personal chat.
May you repeat, Joanna? It's cracked a little bit for me.
Okay, so how do you envision the role of IEA and its federated societies in Industry 5.0 post-pandemic situation?
That is a good question. As I said, we are implementing a special committee now. In fact, it was implemented last term, called Future of Work and Future of HFE. And the preliminary results from the survey made with our federated society is to IEA to work more in this topic, not only promote webinars that we will do with people from the HFE community, but also to invite people from industry, invite people from other scientific domain that design. We need to dialogue also outside of our community. This is one way to go and involve the federated society as well, the experts from the federated society. That is one point we are working now. Secondly, we are identifying and compose the committee with people from developing countries and developed country. We should announce very soon the new chairs, co-chairs, and also representatives from each region in order to organize regionally conference symposiums and also discussion, like I said, to motivate the federated society, and also with the support of IEA, like we are doing in Colombia. We had in Colombia, we have been discussing with this big industrial group in Colombia since 2019. And right now, they are interested to become not only corporate sustaining member of IEA, but developed training with our assistants, our technical committees, and also developed a kind of observatory for field of work. We have been doing our incursion to the industrial world as well. And we would like to motivate the Federated Society to do the same. Because we needed to understand, and our first experience in Brazil, several universities have been working, implementing the preliminary studies related to Industry 4.0 and 5.0. The first results are saying that it's not only cost, like somebody sent to me a question here, is the universe of the industry. We needed to understand, in my experience as engineer, I work as engineer, production engineer in a company, in a Japanese multinational company, then in a Brazilian company. The companies, they needed to reduce costs, but more than that, we are engineers to solve problems every day. And HFE is so important to solve the problems. So we needed to be shameless, to be honest. We need to be shameless, knock the door, and try to understand the requirements, the problems the management are facing. That is what we call go to the field, go to the wild. And of course, we have already in our university industrial engineering departments, computer science, etc. But we can do also using HFE. We needed to understand the request, the demand posed by the management. We need to be skillful on that. And we should be trained on that. It's not difficult. I have been training, and we are training our students. For example, just to give a small piece for the industrial engineers, in the last 20 years, I have been doing this kind of training. I assigned for a group of 3 undergrad students to define what kind of company they would like to make the field study. And they go to negotiate their entrance in the company. They start from the undergrad to be skillful, how to address the company, what the company are interested. And they go, of course, have been trained on that. The same for the master students and the same for the PhD student. So we use the influence of the university to open the doors and explain our methodology. Our methodology using HFE is to solve their problems. Once you open the door and they feel that you are doing a very good job, work as management, you consider the prescribed work made by management, but you review, like we did to the Brazilian oil company, see the constraint maps, and you prove, you have data. So they started to have both view, because the engineers and management, the directors, they have one view, what's going on in the field, what's going on in the bottom line, because they are not feedback to collect this data in everyday life of the industry. And this is a way to get the production system much more efficient, like we did in the oil industry. We went to a very complex system, and we realized to do this. So, and we moved to emergency response system. Of course, demands lots of energy and social construction to do so. But I'm truly convinced that you can do in Indonesia. You have a red relationship in logistics, in product design, in management, in human resource. We need to do in HFE. And that is possible. Make the activity analysis, ethnographical studies to understand what's the problem from the point of view of the workers. Doesn't matter if it's an engineer or a director or the bottom line work, okay? So the experience we have here, especially in the Industry 4.0, we have a big multinational from Sweden. They bought all the equipment. Now they don't know how to implement. So because they don't know how the works they have, what kind of skills. Now they started to map what they have, to define the requirements in terms how to make this digitalization, what kind of training their workers, experienced workers need to be trained in order to operate the new system. It's amazing. It's very, very interesting. So I'm truly convinced that you can do the same there. And we can start, my dream is we can start a project with the IEA, ACD, CIANIS, and other experts, and that we start a pilot project in Indonesia. It'll be wonderful if you can do that.
Very exciting and motivating answer, Professor Jose, for the question. I think it answered the question from Pak Muslim about the industry. So I would like to go to the next question from Professor Yasirli. So could you, Professor Jose, could you please inform to us about the MOU between IEA and ILO and ILO? Any specific issue about developing countries addressed on that MOU, and how can PI take advantage of the MOU? Thank you.
Very good question. Thank you, Professor Yasirli. My view at IEA is the MOU not only should be in the high structure of the IEA, we should bring down to the regional networks, because ILO has a regional office in Bangkok. I would recommend we needed to work together to have ACD and CIANIS have a first meeting at ILO regional office to address this issue related to future of work. I did the same in the previous term with Yushi Fujita and Andrew Todd in ILO regional office in Latin America, in Lima, Peru. We visited the representative, the director there, and it's very, very interesting because you have at ILO industry, employers representative, employees representative, the unions, and also government. It's very, very important for us to visit as regional IEA regional networks to prepare this visit as soon as possible. And also, after that, it's important to visit. I'm not sure if you have national office in Jakarta, but it should be addressed if there is, and to visit them in order to develop a national project. Of course, in Brazil, we have ILO office, which make it easier for us to address them, because we know people in the government, we know people in the Industry Federation, we know people in Union Confederation. And I would recommend to have contact with the stakeholders in order to start the discussion, because you can do both. You can start from national level and go through regional level, and also to work from IEA level, EC, Executive Committee, and go through along with the regional network and fix an appointment. This, to me, is very concrete. We need to move, and we need to talk with them. The first contact in Lima, Peru, is open the doors. Again, we need to be shameless. We needed to arrive and knock on the door and say, hey, we are IEA. And IEA is not the executive committee. IEA is the entire structure. Everyone, PAI, ACD, CIANIS can talk on behalf of IEA. This is the direction we would like to work together and make progress. But don't forget to have the case study. We learn as industrial engineers or computer science or system engineers as well through the case study in depth. This is really, really interesting. For example, my students now, these COVID preliminary results, if from my students that get into this oil company in Brazil, They have around 70,000 workers in this oil company, and lots of engineers go there. So we needed to set up a network of our students inside these big companies to facilitate this view of HFE. It continues to have a collaboration in terms of research and any other kind of projects. So I'm not sure if I could respond, Professor Yaciel, but I try my best.
Okay, thank you, Professor Jose. So I go to the Slido here. As we see, the first question is from Shamsul Arifin from Brawijaya. Professor Jose, can resilience be measured? It seems that resilience is an abstract or qualitative concept, and it will trap us to the same road as safety culture in quote road.
Oh, this is a very good question. As I mentioned, very briefly, of course, this topic is we are revealing from the reactivity of the pilots. This is the opposite of resilience. So we should work in these aspects to make the system more resilient, safer, productive, effective, efficient. So we needed to address this issue, and the methodology, ADFE methodology, reveal this. I think one approach is my approach, tested in the field, especially in complex systems, is analyzing the reactive made by the pilots or by the firefighters. We could understand the brittleness. We studied resilience by identifying the brittleness in the system. And this is the methodology I have been talking. Of course, it's very schematic in my presentation, but we needed to go to the field and map how the activity is performed. And we could, you needed to map this activity like we did with the pilot activity and identify the brittleness in each part and why things happen bad or good. And this is so important because in the company, there is no sector to do so. We have safety engineer applying regulation. But this again is work as measured. It's not work as done. Anyone needed to understand first what it means, the regulation. But somebody work under pressure, economic pressure, cost reduction, etc., is not mapped. So it seems everybody comes asking to the work to digest all these prescribed rules in order to do their job. But we don't know how the work do the job. And our role is to review how the work do the job. Because most of the time, he or she sacrifice her health or finish in accident when they cannot have control of their activity. Okay? So this is one way to go. And briefly, I would say, in our study with the firefighters, we stage simulation. You can do several levels of simulation. You don't need to be in the fire or in the catastrophic event because it's danger, but you can simulate and you can understand, they have a better training and they have a better performance of the firefighters during any kind of emergency and design more protection, more efficiency, and cost reduction as well. HFE can be used to cost reduction as well.
Okay, thank you, Professor Jose. So I will keep the questions, I think, for now, before we go to the second session of the keynote. So I would please keep the questions running. And if we have time, then we can go back to the questions. So thank you very much, Professor Jose, for your talk. I hope that you can still stay here with us for the second.
Yes.
Yes.
Oh, yes. Oh, yes. It will be my pleasure. Yes.
Or you can stay the whole day. That's also fine.
It's my pleasure. Talk about this. Okay.
Thank you very much. Thank you very much, Professor Jose. Hope that you can still stay with us for a couple of more minutes. So I would go to the second keynote speaker that we have today. Welcome, Dr. Richard Hanowski. Let me introduce you before we start your talk. So glad to have you here, Dr. Richard Hanowski. Dr. Richard is a senior research scientist and director of freight, transit, and heavy vehicle at VTTI, or Virginia Tech Transportation Institute. Richard has enormous experience on a lot of fields regarding transportation, human factors, simulation, advanced system development and testing, naturalistic driving, human performance evaluation, and so much more. And he has written over 300 journal articles, conference paper, book chapters, and technical reports. So today we will hear from him about his talk with the title Transportation Human Factors Research in the Age of COVID-19, New Opportunities and Research Program Pivots. Dr. Richard, yes, glad to see you. So the time is yours.
Okay, so thank you so much, Joanna. And I wanted to, let's see, I'll get my presentation set up here. Thank you to Dr. Guajardo and the rest of the organizing committee. And you can see this okay, I hope?
Yes.
See, okay, thank you. As Joanna mentioned, I'm a researcher at the Virginia Tech Transportation Institute. The research that I am involved in deals with commercial trucks and buses specifically. So as human factors is kind of a niche area, maybe within industrial engineering or mechanical engineering or psychology, depending on what area you're from. Transportation is even a bigger niche within human factors. And then even more so is the trucking and bus research that I do. But I think this is a great opportunity to talk about the research. It's very applied, I should say, right up front, though I am part of a university and it is an academic setting. The work that we do is very pragmatic, very applied. So clients will come to us, whether that's the federal government, state governments, or companies with a specific research need and issue, and we will do our best with our team to solve that. So just as an overview of the presentation that I'd like to give today, I'll give you a little introduction of myself and my team. And then, given the theme of the conference, dealing with the pandemic and all, I thought we could, obviously it's a struggle for researchers, but I'm going to talk about a new research project that we started because of the pandemic, because of COVID. I'm going to talk about a research program that was ongoing that we had to make a pivot. We had to change a little bit. And then I'm going to talk a little bit about some ongoing research that I'm working on with Miros in Malaysia. That's really critical, I think, to a reopening of the ASEAN economy. I won't spend a lot of time here. It was a great introduction. Thank you, Joanna, for that. But my background, certainly has been both in academic. I worked with General Motors for a period of time, Battelle, and then VTTI. So the research that I did, I've had a lot of opportunities to work on some very interesting projects that have had some impact on regulations in the US and even more broadly international. You may not have heard of me before, but maybe you know a little bit about the research that I've done. So driver fatigue is a big area that I've dealt with, and I've done a lot of research to support the hours of service regulations for truckers. That's how long truckers can drive, how long they have to take breaks for, how long they have to have a reset over, say, a weekend time. Driver distraction, that's probably the most impactful work that I did. We were the first research that quantified distraction with trucking, and then that certainly bled over to other driver modes as well. And one of the things that we're very proud of, we really pioneered the whole naturalistic driving method. And I have a video of this. So this happens to tee up with fatigue. So naturalistic driving, you might think of research in a laboratory or a simulator where you will bring a participant in to collect data. This is a little different in that we have instrumentation on the vehicles themselves, and we record drivers as they're performing their normal duties. We don't tell them what to do or where to drive. We just record what they do. And sometimes we record crashes and other aspects, safety events that occur. And then we try to understand the behavior associated with the causal factors associated with that crash. So this is a fatigue-related event. I'll just kind of show you what this looks like in the videos that we will get in. So again, this is a truck driver hauling 80,000 pounds, driving down the road, but fatigue and nearly kind of goes off the road at that point. So you'll see this again in the US, it's very common. You will see drivers kind of drifting in the roadway. I'm sure that's not just novel to the United States, that you see that as well. My best advice would be just to stay away from trucks that are doing that. Distraction, this was again a very interesting finding. We weren't expecting this at the time, but we did have a number of drivers that would be texting while they were driving and getting into crashes and near crashes. When we found this in our data, we reported it, and shortly thereafter, President Obama at the time put in an executive order banning this from government workers and contractors. And then shortly thereafter, there was a regulation for truck and bus drivers specifically. So what has COVID done, I guess, to a research program like mine? One of the things that it required was kind of a quick assessment and then needs. So staying within the truck and bus realm here, one of the things that some clients came to us with was, we do have a lot of meetings like this on Zoom where we're remote. There is still people, frontline workers that did go to work just like they normally did, and bus drivers, and we're part of that group. So one of the questions that came to us is what kind of engineering controls can we implement quickly to reduce COVID-19 exposure? So the goal, again, was to reduce exposure for bus operators in the presence of COVID-19 and also passengers, right, that also may have to go to work, and public transport is their only method. And so one of the things we wanted to look at, then focus for the study, was air quality objectives and then engineering controls. So things like maximizing fresh air to assist in the dilution of COVID-19, and pressure differential at the front of the bus to encourage flow from front to back, and then filtering and forcing the HVAC airflow. So one of the research tools that we have at the Virginia Tech Transportation Institute is a controlled test track where we can make it rain and fog. So we're able to kind of use that facility to do some airflow fogging observational testing. So to mimic, say, droplets that might come, and look at flow and how maybe that fog might congregate around the driver or the passengers. So, one of the things that we wanted to then do was to get, do these results, get this done very quickly so we could get it out to transit agencies so they could, put in these very temporary controls so they could keep working to keep their drivers safe. So, you might think in terms of implementation, maybe a suboptimal method might be to turn the defrost off, driver opens the window, the rear hatch is closed, and maybe a no mid barrier. But there would be other optimal approaches that we came up with as well as part of the design process. And like many of these human factors engineering designs that I'm sure you have been involved in, there's never a silver bullet, never one thing that typically that'll fix it all. And in this case, we did determine that there was a layered approach. So again, depending on a transit agency, what they have at their disposal, things like filtration, photocatalytic reactors, fogging, sanitation, UVC, bipolar ionization, and ventilation could all be used as a layered approach to reducing risk. So that prevented then again, or I should say COVID-19 allowed the opportunity to kind of develop some of these studies, these projects, these design projects that normally we wouldn't have thought of, if the pandemic hadn't happened. But we have another number of programs that were also impacted where we had to adjust in some degree the research to be able to continue on, because it was type of research that we felt was very important, that needed to continue on. But just like this conference, right? This is a pivot where we're not in person, we're doing this by Zoom, so we can still march ahead. And the particular study that I wanted to talk a little bit about has to do with teen drivers. So newly licensed teen drivers in the United States, teenagers at about 15 years of age or so will start learning about how to drive a vehicle. But one of the things that they're not taught very well is how to operate that vehicle around heavy trucks, commercial trucks. So we had developed a program funded by the National Safety Council, the Federal Motor Carrier Safety Administration, to develop a program for teenagers, for drivers as they begin to get behind the wheel and start driving, to teach them about the risks, especially with commercial trucks. So one of the things that we know about teen driving is that it's over a third of all deaths for teenagers and again, I should preface this with all of these statistics. These are United States statistics. I'm not exactly sure what it would be like in Indonesia or other Asian countries. But about a third of all teen deaths occur behind the wheel or in a roadway crash. And you can kind of see some of those other statistics. So, about 7% of licensed drivers in the US, that's what teens make up. But they're about 14% of all road fatalities and 20% of all crashes. So widely overrepresented in this particular crash type. And male drivers are the most risky, 2 times more likely to die in a crash than female teen drivers. So this program, we got this underway about 3 or 4 years ago, but it was really kind of a long-standing and grew organically out of some earlier research that I did. This is some dissertation work that I did back in about 1998 or thereabouts. We did one of the first naturalistic studies with trucking. And one of the things that we found, which was a little controversial at the time, was that of every 10 crashes or so, 8 of them are caused by or initiated by the light vehicle driver, so the car driver, and it's not the truck driver. We often think of the truck driver as being the really dangerous driver that's on the road, but in fact, if you look at crash causation studies and look at fault crashes, you see that it's the car drivers that are primarily to blame. Now, when a car and a truck crashes, most of the time the car is going to end up on the wrong side of that as well, and most likely to be in a fatality. So more specifically, then in getting back to teens, if we look at this blanket of time, about 4 or 5 years between 2014 and 2018 in the US, there were 160,000 teens involved in a car-truck crash in the US. About 120,000 of those teen drivers were involved in property damage only. but then a little bit more heartbreaking, about 38,000 teen drivers either had an injury or were in fatal crashes. And about 13 times more likely to result in the fatality for the teen driver compared to older drivers. A lot of that could also be because of seatbelt use and other aspects associated with this. But this is an example, again, of a typical type of crash that a car driver, and in this case, a teen driver, can be involved in with the truck. So, a different situation where there's merging or the lanes go from 2 lanes to 1 lane, who has right away, rather than slowing down and letting the truck go by, they try to pass and then end up in a very serious crash. So one of the things that we try to teach these teenagers is that, why would trucks be so dangerous for them? And, they typically weigh 80,000 pounds in the US. They have much longer stopping distances, which is a bit of a surprise to some teenagers. We found they think that because these trucks are bigger, they can stop faster, but it's actually the opposite. They need more distance to stop. And they have limited visibility. If you've ever been in the cab of a truck, you see that it's difficult to see, especially at the side or if there's a vehicle behind you or at the side of you. So traditionally, share the road education has included some information about sharing the road with trucks. This might be in form of a textbook or some discussion of it, but the depth of the content varies greatly from, one either a school that teaches this or state that might teach this. And one of the things that we identified was that there's a lot of room for improvement. Again, this is when you're going to probably address this issue when someone gets first behind the wheel. So that's a really great opportunity, we felt, to be able to impact this knowledge on drivers. And one of the things that we also learned with teenagers, they prefer more a kinesthetic learning approach. So, learning by example, experience, seeing videos, which we have in our naturalistic driving that depicts these real life scenarios. So I showed you a couple of videos earlier from our naturalistic driving study. We have hundreds of crash videos that we're able to pull up and show. And so that's one of the things that's very engaging. People are very interested, obviously, in seeing crashes and what maybe the driver did wrong, so they will not make that same kind of mistake. So one of the program that we put together is really designed to fit into one class period. It's about 15 minutes of in-class presentation that includes some of these sobering facts, about light vehicle, heavy vehicle crashes and the characteristics of trucks, just the physics of being large and their braking and their visibility. Showing these different crash images. And then we try to really kind of, limit it on some sharing the road tips, and we limit it to 5. So hopefully that'll be very impactful and something that a teenager will remember when they leave. The other thing that we try to do beyond the 15 minutes of in-class presentation is to do hands-on demonstrations. So we will bring one of our big trucks to the school, allow, the teenagers to get up inside it. They can take a look at blind spots and have an opportunity to, with this hands-on approach, to be able to continue our education. But obviously COVID put a big damper on this, but kids were still wanting to drive and turning 16 is 15 and 16 in the US when they can get their license. So we had to think of an alternative approach. And so just like this conference, what we did, we ended up having to cancel schools that we had planned, and we turned our educational information into video series and developed a website. I think this is getting recorded. You can find this on the web, but if you can't find it, just send me an email afterwards and I'll be happy to send this to you. But there's a series of, share the road with trucks, information, tips on blind spots and not hanging out. It's called the no zone. So it's an area around the side of the truck where you shouldn't be, how to properly pass trucks. And then what we saw in that one video of that crash was just not getting squeezed out by drivers. So they're pretty quick, they're about 6 minutes long, attention span maybe of teenagers is a little bit low. So we wanted to make these kind of impactful and short and little bite-sized pieces, but that include videos and photos and voice durations. And I'm gonna play one here. It's a couple of minutes long, but you can get a feel for what these are like. And if you're interested or you have a teenager that might want to see this, I would direct you to them, but I'll just let this play here for a little bit anyway. Okay, so you get the point of this and how these go. And again, if you're interested, please take a look. I encourage you to look at these. So, for this particular project, then when we had to do this, a bit of a pivot, what we wanted to do with the program itself was to, again, supplement traditional textbook only education methods. We had reached well over 1,000 soon-to-be drivers. And since then we developed our website. We've had about 3,000 users. It's cool. I'm sure there's probably people from Indonesia in there as well, but over 70 countries have found us, and 48 of our 50 states. When you do a education program, as you all know, it's really difficult to understand if it's effective or not. We do tests afterwards and found that that there seems to be some improvement in knowledge. But we have a lot of high schools now request us to come every year. But again, adapting to COVID-19. So the last part of my presentation I want to talk about is a little philosophical maybe, but it deals with a program that I'm currently working on with Miros in Malaysia. And something that I think could happen is as economies reopen, and I think maybe the US is a little bit ahead given the vaccine situation, but you'll start seeing as people get back on the road, will there be increase in traffic and road crashes? And that's what I fear may happen. So this is the research project that I'm again working on this topic. And you can see these handsome guys on the right-hand side there, are the three on the bottom are from Miros. And so just to give you some ideas, some context on this topic, in the US, again, between 2014 and 18, there was about 2,000 what we're calling truck-struck crashes. So that's when a car or a truck will run into the back of a large tractor trailer. So rear end a tractor trailer. So that's these big red bars are these what we call truck-struck crashes. The yellow line are the motorcycle involved crashes. And you can see this overlap where they're involved in roughly about, in 2018, 5% of these fatal truck crashes. If you look at just raw numbers, again, the US isn't anything like Malaysia, and certainly nothing like Indonesia with respect to motorcycle usage. But over this 5-year period, a little over 300 of these types of crashes, truck crashes involving motorcycles, and a little over 100 fatalities. This data in a little bit more detail, and found that about 3/4 of the crashes involving, again, these motorcycle truck crashes were two-way divided highways. Over 80% had a high speed limit, so likely that speed was a factor. And when we look at the other end of the scale, less than 1% were speeds under 35 miles an hour. In terms of the road conditions, most of these crashes occurred when the road was favorable, meaning dry. So it wasn't an aspect associated with, wet, icy, slushy. That only happened in about 1/4 of those, or 1/5 of those. And then the striking vehicle, which is the motorcycle, was speeding in over 1/3 of the fatalities. And when we looked at specifically at 1 year of data, we were able to drill down, and about 1/4 of the fatalities involved distracted driving. So we ran these analysis on the data that we have available in the US, and then we had our Malaysian counterparts do the same thing with their data set. And in 2020, the data from the Malaysian Road Safety Department indicated that there were 1.26 million registered heavy trucks. That's about 4% of the total of all vehicles in Malaysia. About 4% of those are tankers, and about 14 million motorcycles were registered, which is an increase from a previous year in 2018. And very interestingly, very unlike the US, motorcycles make up nearly half of Malaysia's 31 million vehicle fleet. Now, if you look at, in Malaysian data, motorcycles account for about 12% of the annual mileage, but 2/3 total fatalities, so 4,000 lives lost. That's annually. We had, I think it was 100 lives lost in the US over a 5-year period, so you can kind of see the difference, the scale that we're talking about in terms of lost life. Again, the most common crash type for motorcycles is a rear end crash with a heavy truck. It's about 1/3 of all crashes, of motorcycle crashes. And again, they have all the rear end crashes with heavy trucks, motorcycles, truck struck were most common, 56%, and 88 fatalities. So some of that same analysis that I showed you earlier with the US data, we replicated that with the Malaysian data, and you can see these plots but you'll see the scale on this side here. So I think in the US it was something like 5%. Now we're close to 50%, which is obviously very significant and very troubling. When we're looking at the reason why these occur, data that we have when we drill down a little bit, about 50% occur on two-way divided highways. Only about half were in higher speed zones. Again, mostly occurred in favorable road conditions as compared to unfavorable. Alcohol is not an issue, obviously, in Malaysia, and that's probably the same or not as big an issue for sure as it is in, say, in the US. So again, speeding for the Malaysian motorcycle, these crashes was not found to be the main cause, which was surprising. But this was, and this finding was really surprising. I wouldn't see this in the US, and I'd be curious to find out if Indonesia has a similar circumstances. But for most of the police investigations that we saw with the Malaysian data, most of these occur when a truck is like broken down on the road, and it's nighttime, say, and the motorcyclist fails to detect. He doesn't see this broken down truck and will just run right into the back of it, and it's almost a near fatality. So if you look at, again, comparison of the US and Malaysian data, it was kind of an interesting exercise, an interesting collaboration, but this rear end crash type with heavy trucks appears to be growing. But in roughly that same year period, over 5 times more Malaysians died in motorcycle trucks crashed as compared to US motorcyclists, which is shocking given the size of the population and the vehicle fleet. But not surprising given the dominance of motorcycles in Malaysia and as a proportion of the country vehicle fleet. Obviously it probably goes without saying that when there is a crash between a motorcyclist and a truck, it's exclusively the motorcyclist that's going to die. The truck driver is going to be fine. So it shows the vulnerability of the motorcyclist crash configuration. We need countermeasures, right? So this is a great human factors engineering type problem. We know that there's an issue. What can we do about it? So again, just maybe it's serendipity, but about 10 years ago, we worked on a project for the Federal Motor Carrier Safety Administration looking at a rear signaling countermeasure to mitigate rear end trucks crashes. So we developed some different designs and prototypes for this, both open loop and closed loop systems. The concept of this technology, this countermeasure, was based on driver distraction. So we were doing all that driver distraction work and saw that a lot of drivers aren't paying attention to the forward road. And why else would you run into the back of a tractor trailer unless you're not seeing it? Maybe in Malaysia they're not seeing it because it's broke down on the side of the road and there's no lights. I'm not sure. But when it struck in the middle of the lane, you must think that maybe one possibility is that the driver is distracted and not paying attention. So that was our hypothesis that we went into developing this countermeasure. And one of the measures that we looked at to evaluate the efficacy of it was time to look up. So in our studies, we would have distracted drivers that were looking away, and we would flash this countermeasure on and looked at their braking and steering and time to look up. So this gives you an example.
Sorry, Richard, I think you are on mute. You are muted, yes.
There we go. Okay. Let's see. So you can see the trailer, the flat lights flash to get the attention. And again, we use this both on open loop systems and closed loop systems. And the difference of those is that in this case, there's a radar on the back of this trailer that detects the car that's moving in and will flash the lights for depending on the time to collision that the car is approaching. And so there's a number of different configurations that we tested with that. It didn't go anywhere because the government in the United States was worried about all these extra flashing lights on the back of the trailer. But lo and behold, 10 years later, and just last year, a company went out on their own and asked for an exemption for a light that's like this, that flashes when the vehicle is braking. And there's been some testing that's shown, again, in a real world setting, the positive effectiveness of this. And this system's pretty a dumb system, if you will. It's open loop. So when the vehicle is braking or slowing, the light flashes. There's no radar or anything special about this. Okay, so to summarize just my presentation, COVID has had a profound impact on really all aspects of our lives, including the research that we do as human factors engineers. As a scientist, it's always going to be important to be flexible and be mindful of ways in which new research can quickly be spun up, in this case, to help in the pandemic. And it's also important to understand how research programs can pivot, and you really need to think outside the box. because what that can lead to is new and innovative approaches. And we're seeing that in really all aspects of our society, whether it's working from home, which may carry on beyond the pandemic, or other shopping trends and other things that we do that could change. I think research is also in that same situation where there will be new techniques and approaches that are developed due to the pandemic, but maybe turn out to be more efficient or effective ways, whether it has to do with research in itself or specific designs. And a concern that I have is when countries begin to reopen from COVID, road safety issues could spike, presenting opportunities for quick reaction to implement proven safety initiatives. But it's something that government officials, advocacy groups, road agencies, and researchers should really be mindful of. Okay, so that is my last slide.
Okay, thank you, Dr. Richard Snowski, for your talk. It's very insightful. I think everyone agrees. I couldn't agree more that COVID-19 has profound effects on many aspects of our life, including our research. I think because we also focus on humans in our human factors research, so it has a big impact. But it's very nice to see how you outline sort of new research initiatives despite the COVID, and how we can identify new opportunities in our research going from the COVID-19 situation. Personally, I'm very interested to see the sharing the road with trucks program, because I have two teenagers at home.
Yes,
one is 15 years old. And he's already shown interest in driving. So I'm very interested to share the videos to my eldest. So please share the links, Richard.
I will do that.
Thank you. So we go to the questions here. I see a number of questions in the chat box. So first is from Ibu Ratna Purwaningsih to Professor Hanauski. The number of accidents in male teenagers is higher than females. Is there any research that tries to answer the causes of this evidence? So that's
actually, that's a great question. And there has been quite a bit of research on gender differences in crashes with teenagers. As you get older as a man, I think you start to settle down, but a 15 or 16-year-old teenager, they're very aggressive. They want to show off. They're maybe driving with their friends, which is also increases their risk factor when they're driving with someone else that's not a relative. So there are a number of aspects. It's been really widely studied for that, but it's just, in a nutshell, it's just men at that age are more aggressive, and even so in driving.
Okay, thank you. The second question is from Ibu Nurul Huda from USU. Is there scientific evidence or a relationship between road crashes and traffic culture?
Oh, yeah, for sure. Yeah, the whole safety culture thing is very interesting. I have one of my researchers, that's what they focused on. I would be happy if you want to, there's my email there. If you want to send me just a reminder of that, I can send you some information on that specifically with respect to safety culture. Yeah, we recently finished a study where we did some work with a number of trucking fleets. And again, you have to think, how can that translate over to what other, maybe other drivers that you're thinking about? But again, my stuff's focused on fleets and industry. But these fleets is very interesting because they weren't very had very good safety records. So we watched them, and then they turned their safety records around. So they went from some of the worst safety to some of the best safety. And we interviewed them. We went with them. We wanted to understand what did they do to turn this around. And we documented that. And part of this understanding the safety culture was certainly one of those. And there's a lot of complicated aspects with safety culture. Different companies are at different, it's like a journey talked about on that. But yeah, having safety as a priority within the company. That comes right down from ownership and managers. Those are all very critical aspects for reducing road crashes.
Okay, thank you. So I have here one of the experts in ergonomic and safety transportation in Indonesia, Pak Hardianto Iridia Study. Pak Dadi, would you like to raise a question?
Okay, thank you, Bu Jo. Good evening, Rich. It's good to see you
Great seeing you
in this conference. It's a great presentation. Thank you for sharing the presentation. I have one question. Do you think the results you obtained from the MIRROS project are applicable here in Indonesia? And the second follow-up question is, would you be willing to help us out in leading similar research in Indonesia? And what do we need to do if you are willing to do that? You know, how the situation here in Indonesia versus in the US, for example. I mean, the paperwork wise. So I don't know whether it's a feasible option for you or not. Thank you.
Yeah, no, absolutely. That's a great question. And I'm kind of honored by that kind of the request. With Malaysia, it's kind of interesting. Again, looking at the differences with motorcycles, just for instance, in terms of the volume of motorcycles that they have and the number of crashes that they have. I did a quick little search, and I think Indonesia is like 10 times the number of motorcycles that there is in Malaysia. So what a fantastic study, as a collaborative effort that we could maybe me and you and MIRROS could do a follow-up study where we also look at add Indonesian motorcycle crash data to this as well and do a similar type of analysis. So that would be kind of something that would I think help move the needle forward. I think before you can kind of understand with countermeasures and what can we do to solve a problem, you have to really clearly understand what the problem is and the magnitude of the problem. And so that's really always a first step. But the data, I've not worked with Indonesia data. I'd really like to collaborate. That'd be fantastic because I think there's a lot of things we can learn really both ways to help and save lives.
All right. Thank you. Thank you so much.
Okay. Thank you. Before I invite Professor Jose to be back in the Q&A session, one more question, Dr. Hanauski, from Ibu Manik Mahachandra from Undip. Dr. Hanauski, thanks for sharing. What do you think about passenger roles, a distraction or an effective co-drive, and how do USA cope with this?
Yeah, great question. That's a very insightful question because I like questions like that because there's not a right answer there. So it depends. Passengers can be very helpful or not so much. So let's talk about the teenage driver situation. If you have a teenage son, I probably don't let his buddy ride along, especially as a new driver, because they're distracting to that person. But maybe you are going on a long journey and you have your spouse with you or a friend that can help you stay alert from a long journey. So in certain cases, they can be a countermeasure to fatigue where they're engaging you in, say, conversation. They're an extra set of eyes that can watch for things that maybe you don't see. So great question. Passengers can be both good and not so good. So there is certainly some onus of responsibility on the passenger to understand their role and not to be distracting. And again, unfortunately, with the young males in particular, that can be a very negative. And the data is pretty clear on that. We've done a number of studies where have shown that that's an increase in risk if you're a male teenage driver and you have a passenger.
Okay, thank you, Richard, for your answer. So I would like to invite back Professor Jose for the Q&A session. If the organizer can spotlight also Professor Jose for this session, please.
Yes. Can you hear me?
Yes, very good, Professor Jose. Yes, also I was informed, I'm informed by the organizer that we have more or less effectively 10 minutes to close the session. So I would like to go back to the question that has not been answered. Maybe from Bunafi from ITS, from ITS. Professor Jose, are there challenges in building interaction between stakeholders in solving ergonomic case there? Thank you.
Oh, it's a very good question, because in our universities, we are not trained to deal with the stakeholders. We are due to design workplace, etc., but we are not instructed and trained to understand the work demands, the management demands, the management requirements. We are not trained to interact with the company representative or union representative or government representative. This is a very interesting school on HFE in Europe. They developed, with the support of the psychologists, try to understand what is the real request. And this is something to be developed along with the ethnographical methods. And especially in France, where I studied, and the US, I've been working at Ohio State University with Professor David Woods, but in the US, you have the people from naturalistic decision-making, for example, conference, they understand how to do this. And it's really interesting, because it seems if we can understand really what come from this ambiguity request or masked request, it's like to peel a pineapple. You know, the metaphor I use to my student is the pineapple juice is wonderful, and you have in Indonesia as we have in Brazil. But to peel the pineapple, you need to be very careful. It's the same you should have in the interaction with the management requirements. We need, for example, regularly the managers, they talk in their language, and we needed to understand and go through to see how unfold this request. If it's cost, let's go to the bottom line, the production system, and try to understand from where come this cost increasing, for example. And we can review that is not only cost increasing, it could be related to quality, it could be related to training of the workers, and it could be related to the equipments not calibrated. It can be, for example, the instructions made by the methods not to be okay. So it's a lot of issues can be revealed and modeled in very different ways, from block diagram, concept map, whatever. It's not a recipe for this. It's important to go to the wide and to have this interaction and go through the organization and try to understand the point of view at different levels.
Okay, thank you, Prof. Maybe one last question. I would like to take the question from the chat box. It's from Ibu Dian from Trisakti. So, Professor Jose, we face the challenge of educating the public, other than industrial world, on how to stay healthy and productive during the pandemic. Do you have any suggestion on how to optimize ergonomics awareness education in the community?
My fast and short response is HFE experts needed to learn how to use the social media, to make short videos, to be sent by WhatsApp, by WeChat, by any other issue. I could verify that there are several examples, like how to work from home and to make popular the concepts. It seems we are a little bit autist. We talk much more to a very close scientific community through our papers. We needed to be open and try to use other ways to communicate and make understandable for the general public. It seems we don't do that. we talk too much closely to our community. It's a big challenge for us. We have been trained at university to talk to our students, to talk through the papers and to use some language. Scientific language is very complicated to general public to understand.
Okay, thank you. Sorry for the other question. I will not be able to address it to the keynote speakers, but I think you are all open to contact Professor Jose and also Dr. Richard to correspond more. So on behalf of the organizer, I would like to thank both of our distinguished keynote speakers, Professor Jose Orlando Gomez, thank you for your insight. Also, Dr. Richard Hanowski, thank you for your insight as well. It has been a very insightful, engaging, exciting, and I was not able even to cover all the questions. So it is very, and we are also running behind. So it's very, very nice. I really enjoyed your both of
Joanna, a last request.
Yes.
It was very nice to watch Professor Hanowski and so on. May you take a picture of the screen? Yes.
Yes. So maybe I will give back to the organizer, so you can arrange a photo session.
Yes.
Oh, that is wonderful.
Yes, of course, Dr. John. Okay, maybe I thank you once more for Professor Jose Orlando Gomez, Dr. Richard Hanowski, and of course, Dr. Joanna Reni Octavia for the remarkable sharing. So before we move on to the next session, we would like to invite all the participants to take a group picture first with our special keynote speakers. With our special keynote speakers, Professor Jose Orlando Gomez, also Dr. Richard Hanowski, and also to our special moderator for today's session, Dr. Joanna Reni Octavia. There will be several slides for this virtual conference room meeting, so we will take it per slides. We are going to start with the first slide. 1, 2, 3, please hold your beautiful smiles. Nice. And
Excellent.
let's move on
Thank
to
you.
the second slide. 1, 2, 3. Perfect. To the third slide. And then to the fourth slide. To the fifth slide. Give your happiest smiles.
Good.
And to the last slide, the sixth slide. 1, 2, 3. Great, perfect. Thank you, everyone. Thank you, Professor Jose Orlando Gomez. Thank you, Dr. Hanowski, and also Dr. Joanna Reni Octavia. Thank you so much.
Thank you.
Thank you. Take care.
Yeah.
Bye-bye.
And now we have a thank you sign for the keynote speakers and for the moderator also, an ear certificate for you for being a keynote speaker for today's session. Thank you very much, Professor Jose Orlando Gomez, and also thank you very much, Dr. Richard Hanowski, for being the keynote speakers for today's session. And also we have an e-certificate for our moderator today. Thank you very much, Dr. Joanna Reni Octavia, for being the moderator for this session.
Thank you.
Thank you.
Thank you.
All right. And please, for every participant, kindly fill the form shows in your screens right now to make sure that every participants are present during this conference. And the link for the attendance will be also shared by the committee in the chat box. Okay. Thank you very much. And now, to refresh our brain first, we are going to invite Dr. Heru Prastowo to lead us to our ice-breaking session or our relaxation session. And please, kindly open your camera first for every participant, and a little information that in this session, every participant can get chances to win one of the awards. So please show your enthusiasm and be the most active participants in doing the relaxation. So without any further ado, to Dr. Heru Prastowo, the time is yours.
Thank you. Ladies and gentlemen, let's take a moment to relax. We follow the movement according to the lyric of the song. This song is a children's song. Please come rise on. There will be prize, one for the male and one for the female. The committee will judge who is excited. The word on the head, shoulder, knee, toes, eyes, ear, mouth, and nose. You can do it sitting, and please slide your chair back.
Recording in progress.
Okay? Please, operator.
Head, shoulders, knees, toes, eyes, ear, mouth, and nose. Head, shoulder, knees and toes, knees and toes. Head, shoulder, knees and toes, knees and toes, and eyes and ear and mouth and nose. Head, shoulder, knees and toes, knees and toes. Head, shoulder, knees and toes, knees and toes. Head, shoulder, knees and toes, knees and toes, and eyes and ear and mouth and nose. Head, shoulder, knees and toes, knees and toes. Head, shoulder, knees and toes, knees and toes. Head, shoulder, knees and toes, knees and toes, and eyes and ear and mouth and nose. Head, shoulder, knees and toes, knees and toes.
Thank you. Please, MC.
All right. Thank you very much, Dr. Heru Prastowo. Yeah, and that's it, the relaxation session from Dr. Heru Prastowo. Thank you so much, Dr. Heru Prastowo. Now, just like yesterday, we will have a 3 parallel session for today. The first parallel session will be directly after this announcement until 12 p.m. And for the first room, we'll discuss about human factors and engineering and will be chaired by Dr. Novi Susanto. The second room will discuss about human factors and engineering will be chaired by Ratna Sari Dewi, Sarjana Teknik, Magister Teknik PhD. For the third room, we'll discuss about safety, security, and risk engineering and will be chaired by Dr. Denny Nur Ketamanda. And for the fourth room, we'll discuss about human factors and engineering and will be chaired by Sugiono, Sarjana Teknik, Magister Teknik PhD.
The second parallel session will be started at 1 p.m. until 3 p.m. as your information, and there will be special parallel session at 1 until 3 p.m. at room 1 with the speakers from first, Dr. Rizkiana Sukandi Putra, Magister Kesehatan, and also Dr. Farul Azwar, Magister Kedokteran Kerja, and Wahyu Hidayat Sarjana Teknik, Magister Keselamatan dan Kesehatan Kerja. At this special parallel session at room 1, the plenary session will discuss in Bahasa Indonesia. And at room 2, it will discuss about logistic and supply chain by Dr. Nanik Utami Handayani. At the room 3, we'll discuss about intelligent system and modeling by Dr. Singgi Saptiadi. And at the room 4, we'll discuss about intelligent system and modeling by Yusuf Widarto, Sarjana Teknik, Master of Engineering.
And for the last parallel session for today will be started at 3 until 5 p.m. For the first room, we'll discuss about human factors and engineering and will be chaired by Dr. Engineer Listiani Nurul Huda. And for the second room, we'll discuss about human factors and engineering and will be chaired by Dia Santi Dewi Sarjana Teknik, Master of Engineering Science, PhD. Please do refer to the list given to you for the information regarding the Zoom link. For the participants who are not presenting are welcome to join any room that you feel interested in. And that marks the end of our keynote session for today. Please remember that tomorrow's PEI Congress will start at 7:30 a.m. exclusively for PEI member. You can enter the room starting at 7 a.m.
And also, we would like to remind you to join this plenary session room again at 5:15 p.m. I repeat, 5:15 p.m. to join our awarding and our last session. And yeah, we want also to remind everyone, now you can enter directly to the parallel sessions until 12 p.m. Thank you.